Everything you see around you feels permanent. The chair you're sitting on, the phone or computer screen you're looking at, the very ground beneath your feet. It all seems solid, dependable, real. We build our lives on the assumption that things last. We construct buildings from steel and concrete, trusting they will stand for decades, even centuries. We pass down heirlooms from one generation to the next, believing these objects carry a piece of our history, a tangible link to the past. This idea is so fundamental to our experience that we barely ever stop to question it. This sense of permanence is rooted in one of the most basic principles of physics. You might remember it from a high school science class. It's called the law of conservation of mass. This law tells us that matter cannot be created or destroyed. You can burn a log, but its atoms don't disappear. They simply rearrange themselves into ash, smoke, and gas. The total amount of stuff in the universe stays the same. This principle is a cornerstone of our understanding of reality. At the heart of this promise are tiny, fundamental particles. These are the protons. Alongside neutrons, they form the nucleus of every atom. And atoms, of course, make up everything. You are made of atoms. The air you breathe is made of atoms. The distant stars are made of atoms. And protons are the bedrock of it all. For over a century, scientists have believed that protons are absolutely stable. What if the most fundamental promise of the universe was a lie? What if the very stuff you are made of has an expiration date? It's a wild, almost unthinkable idea. But some of the most brilliant minds in physics have started to suspect that protons might not be forever. They believe that deep within the heart of matter, there is a hidden flaw, a tiny crack in the foundation of reality. They propose that given enough time, a proton can spontaneously decay. It can vanish, transforming into a puff of lighter particles and energy. Physics is really a story of unification. It's this relentless drive, to find a single, elegant explanation for all the seemingly different phenomena we observe in the universe. Isaac Newton was actually one of the first great unifiers. He realized that the force making an apple fall from a tree is the very same force that keeps the moon in orbit around the Earth. Two completely different-looking events. This brings us to one of the most epic and challenging quests in modern science: the hunt for proton decay. It is a true cosmic detective story. The crime scene is the entire universe. To solve this problem, scientists have to go underground, deep underground. Super K is a truly breathtaking sight. It's a stainless steel tank 40 meters tall and 40 meters wide. Okay, so imagine you are floating right in the center of the Super Kamiokande detector. You're surrounded by 50,000 tons of perfectly still, ultra-pure water. The cavern is sealed in absolute crushing darkness, and then it happens. A single proton in a water molecule, after what feels like an eternity of quiet existence, finally decays. According to the simplest grand unified theories, it might transform into a positron and a neutral pion. This phenomenon is called Cherenkov radiation. It's this faint, eerie blue cone of light. For more than 40 years now, these magnificent experiments have been running. They've been watching. And the result of all this effort? Well, nothing. So far, we have found absolute silence. Not a single event has been observed that can be unambiguously identified as a proton decay. Let's imagine for a moment that our future experiments, like Hyper-Kamiokande, finally succeed. They see the telltale flash. They confirm that protons do, in fact, decay. But what would it mean for the rest of us? If protons decay, then everything we see, everything we are made of, has an expiration date. The very atoms that form our bodies, our planet, and the stars in the sky. But wait, there is one type of object that might outlast the Great Dissolution of matter black holes. They are singularities, points of infinite density where the laws of physics as we know them break down. The only significant objects left would be these silent gravitational monsters. Stephen Hawking famously discovered that black holes themselves are not completely black. The evaporation of the last black hole would be the universe's final significant event. So, what is left after the last proton has decayed? We enter what physicists call the dark era. The only things remaining will be the ghostly stable end products of all that came before. In this final state, the particles would be spread so thinly, a photon could travel for trillions of light years. The universe would be a dilute, uniform, and unchanging soup of ghosts. It would be a state of maximum entropy, the ultimate heat death of the universe. Could anything interesting still happen? This journey into the far future, prompted by a tiny crack in the foundation of the proton, leads us to a profound philosophical question. If everything eventually dissolves into a featureless void, what is the meaning of it all? A beautiful sunset is fleeting. The universe, for a time, became aware of itself through us. Perhaps the universe's value lies in the fact the stars are shining. The search for proton decay is more than just physics. We find ourselves at the edge of a great mystery. The story of proton decay is a perfect example of science at its most thrilling and most challenging. It's a place where our most elegant theories clash with the stubborn silence of our observations. The next generation of experiments like hypercameo, it's a testament to our relentless drive to know. We are cosmic detectives. The case of the decaying proton remains open. So, where does this leave us standing on our small planet? The possibility of proton decay changes our perspective on everything. We are like figures in a cosmic sculpture, carved from ice on a warm day. This realization is both humbling. Perhaps meaning is not contingent on permanence. We are the universe's way of witnessing its own transient glory. It's a beautifully cyclical idea. Ultimately, we are left with a sense of wonder. The universe is vast and mysterious, and the fact that we have the capacity to appreciate its grandeur and question its nature is perhaps the most wondrous thing of all, whether it lasts forever or not.